Welcome to Inverses. This is kind of sort of three parts. The last part is really just, it's kind of weird the way the book wants you to do it. So I spent a day just talking about that. So this was from Friday the 22nd. Welcome to Inverses. So we started here. It says solve the equation to where it says y equals. Well, let me start here at 2. Normally it's subtract or add x over and then divide by whatever's sitting in front of y. And so now I have y equals this. But one of my kids was like, well, why don't I just add y and then subtract 4 and I wouldn't have to necessarily divide. I was like, you know what? That totally works because otherwise we would have gotten negative 3x and then divide by -1, positive would have became negative, negative became positive. We'd have got there anyway. On this one, like I said, subtract the x and then divide. And I mean, technically, it should be -5x plus 9, but the order doesn't matter as long as your signs are right. 9 over 6 reduces to 3 over 2. 5 over 6 doesn't reduce. We got an extra number here. Add it. It combines, and then subtract that. We skipped the last two because we got a good feel of what's happening. Inverse relation is a set of ordered pairs obtained by exchanging the coordinates. So basically x and y switch spots. A and B are inverses, xy, xy, xy. So 1, 5 becomes 5, 1. 2, 6 becomes 6, 2. 3, 7 becomes 7, 3. And so in black, I plotted kind of sort of -9, 10. The inverse 10, -9 is this dot here. 1, -3. 1, -3 became -3, 1. And -5 or 8, -5. 8, -5 became -5, 8. And it was not exact, but it was close. But you can see how the inverse, and we'll talk more about this y equals x line right here. Inverse means you're just going to flip over this line. So this flipped over here, this flipped over here, this flipped over here. We did the same thing here. But I said, well, what about if it lands right here on this line? That's 3, 3. Well, what's the inverse of 3, 3? Well, if you switch these, you're still at 3, 3. You're still at -5, -5. If you're on the line and you flip on that line, you're not actually going anywhere. So steps for finding the inverse. It's real simple. They're going to give you f of x, change f of x to y, or change g of x to y, or h of x to y, or whatever they give you. So f of x becomes y equals. Step 2, exchange x and y. That's what I said back here. Switch x and y. That's like the whole thing about inverse. So now instead of y equals -3x, it's x equals -3y. Notice, like, I didn't just switch sides or anything like that. Everything else stays. X and y switch spots. Solve the new equation for y. So get it to where it says y equals, which is why our warm-ups said solve for y. Well, I got to get this -3 out of the way, so I'm going to divide by -3. And then replace y with f to the -1, f inverse of x. Basically, I told them, look, we can't switch this back to f of x because this is f of x. So we have to call it something different. We have to indicate somehow that we have made this xy swap happen. Well, that's you saying, look, we had some sort of inverse, f to the -1, or g to the -1, or h to the -1, or whatever it is. So we did it again over here. F of x becomes y. X and y switch spots. Notice this is not x squared and y. Like literally the squared stays, the -3 stays, the square roots and the exponents and the divides and everything stays. Literally when you would have written y, you now write x. When you have written x, you would now write y. Everything else stays. Solve for y. So subtract 3, and then to get rid of square, we square root. And then y changes back to f inverse of x. This is the books thing. It's a little weird. It's going to say solve for x. Get it to where it says x equals. We're finding the inverse just without switching x and y. Because I could solve here, and then when I switch x and y, it's the inverse. However, we found it for x equals, and then find the input when the output is -7. Well, input is always x, and output is always y. this is probably why they didn't say, hey, find the inverse, because they still wanted to call it input-output. Output's -7, so y is -7. -7 minus 3 is -10 divided by 2, -5. Here's another one. I'll just let you write this down. It was the same kind of thing. Hopefully it makes sense. Again, we're plugging -11 into y. But we're essentially finding the inverse without swapping it around. You could try these if you want. I just skipped this page because they got a good idea. So now it will say find the inverse of what's happening here. Well, switch to y, x and y swap, add 1, divide by 3, mark it as an inverse. These were not too crazy. Find the inverse here. Just be careful because x minus 8 over 2, this is great, but you got to understand that they're basically two separate fractions, and this guy right here definitely reduces. So this would not quite be your final answer. Back here, 1/3 and 1/3 wouldn't have mattered. 1 and 5, 1/3 and 5/3, and like these didn't simplify. But this particular one did. 8 over 2 is 4, so x over 2 minus 4 would be my final answer on that one. So this was the homework for part 1. Just real quick video. Just remember we're switching x and y. That's the biggest part of inverses.